You've chosen this video because you want to learn how to graph rational functions. Now, rational functions look like this, basically a fraction with two polynomials. Now, when you're graphing rational functions, there are several things that you're going to need to find. The y-intercept, x-intercept, vertical asymptote, horizontal asymptote, whole, three other points, and usually domain and range will be asked for as well. So we're going to break down each one of these and then we'll graph it. If your function is not already in factored form, then you will have to factor it first. Now, if you need some help with factoring, I have several other videos on factoring. This numerator will factor into x minus 8 times x minus 3, and the denominator will factor in x plus 3 and x minus 3. Now you notice that you have a common factor in your numerator and denominator, so that will cancel out. Now when these factors cancel or divide out, that is going to create a hole in your graph. What you're actually going to be graphing is x minus 8 over x plus 3. Your domain is going to be anything that would make your denominator 0. So what you can always do is set each factor equal to 0, this x plus 3 equal to 0, and this x minus 3 equal to 0. Since these are in the denominator, they would affect your domain. So when you subtract 3 on both sides and then add 3 on both sides, your domain is that x cannot equal negative 3 and x cannot equal 3. Now, even though this factor divides out, you still have this restriction for your domain that x cannot equal this 3 because it would make the original function 0 in the denominator. Therefore, it creates a hole in the graph there. So the x value of the hole is the x value of the factor that divides out that would make the original denominator 0. So the x value of our hole in this case is x equals 3. So how would we find the y value then? The y value is found by plugging in the x value into the new equation. So let's do that now. So the y value of the whole is 3 minus 8 over 3 plus 3. So that's negative 5 over 6. So we'll write our whole as a point, which is going to be 3 and negative 5 over 6. Next, let's find the y-intercept. Now remember, to find the y-intercept, you plug in 0 for x and you solve for y. So when you plug in 0 for x, we could even show that f of 0, and 0 minus 8 over 0 plus 3 is negative 8 over 3. Now sometimes this is easier to write as a mixed number since we're going to be graphing. So this would be negative 2 and 2/3. So our y-intercept, we'll go ahead and write it as a point. Sometimes you could just write y equals negative 2 and 2/3, but sometimes it's helpful to write it as a point to remember that we're plotting the point 0, negative 2 and 2/3. Next, let's solve for the x-intercept. Remember, to solve for the x-intercept, you plug in 0 for y and solve for x. And so we're going to set y equal to 0 and solve for x. Now the only thing that's going to make this 0 is if the numerator equals 0. We could multiply both sides by x plus 3 and just divide it out. But the shortcut here would be to just set your numerator equal to 0 in the first place, because the denominator doesn't matter. It's 0 divided by anything except 0 is 0. So we just need to solve for where the numerator equals 0. So we'll add 8 to both sides, so x equals 8. Now again, we're just going to write this as a point so that we don't forget that this is really a point that we need to put on our graph. So our x-intercept is 8, 0. Now let's solve for the vertical asymptote. The vertical asymptote is the x value that would make the new denominator 0. And so we've already solved this when we were doing the domain. So we know that x plus 3 would equal 0 when x equals negative 3. And this is very important that you leave it in this format because a vertical asymptote is going to be a vertical dashed line on your graph. And so we really need this format, x equals negative 3, to show that that is the equation of a vertical line. Now let's figure out what the horizontal asymptote is for this graph. Now, for the horizontal asymptote, you have 3 different scenarios that could happen, so you have to memorize these rules. Now, the horizontal asymptote is all about the degree of the numerator and the degree of your denominator, since these are both polynomials. Now, your degree is the highest exponent of your variable. And so this technically has an exponent of 1, and so does this. And so if you just have a number, then your degree would be 0, or maybe you would still have an x squared left, and then your degree would be 2. So just look for the highest exponent of each polynomial. So there's 3 things that could happen. Either the degree of your numerator is bigger than the degree of your denominator, or maybe the degree of your denominator is bigger than the degree of your numerator, or maybe the degrees are equal, like in this case. So for each one of those scenarios, your horizontal asymptote will be different. Here are your 3 rules. If the degree is bigger in the numerator, there's no horizontal asymptote. If the degree is bigger in the denominator, the horizontal asymptote is y equals 0. And if the degree is the same in the numerator and denominator, then your horizontal asymptote has this equation: y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Now there's a really handy way to remember this. BOBO, BOTN, what this stands for is bigger on bottom. The horizontal asymptote is y equals 0. Bigger on bottom, y equals 0. Bigger on top, none. Bigger on top, no horizontal asymptote, none. So in this case, since the degree is the same of the numerator and denominator, the horizontal asymptote is going to be y equals the leading coefficient of the numerator. So what coefficient is in front of this x? There's a 1 here. The leading coefficient of the denominator, what's in front of this x, it's a 1 as well. So our horizontal asymptote is going to be y equals 1 for this equation. Now it's really important to write your y equals because, again, this is an asymptote, which is going to be a dotted line on our graph, and this is going to be a horizontal dotted line since it's y equals. So now let's go ahead and fill in here all the information that we already have. So we've solved for our y-intercept, x-intercept, vertical asymptote, horizontal asymptote, our whole, and our domain. Now we need to find 3 other points. Now you could find more if you need to, but what we want to make sure when we're finding our other points is that we're not going to plug in x equals 0, we're not going to plug in x equals 8 because we already have those points. We do not want to plug in -3 because we know that that is where our vertical asymptote is. We don't want to plug in 3 because we know that's where our hole is. And so this is very important when we're finding our 3 other points. It can also be very helpful to go ahead and graph everything we already have before we find our 3 other points so that we can see more easily what other points we might want to find. So let's plot our y-intercept. So we have 0, -2, and 2/3. So we're going to put that about right there. And then we have our x-intercept of 8, 0, so we're going to put that right there. Then we have a vertical asymptote of x equals -3. So that is a dashed vertical line that splits our function in half, basically. Our horizontal asymptote is y equals 1, so we'll put a horizontal line on y equals 1. And then we have a hole at 3 and -5/6. So x equals 3, and y is almost -1. So that hole is going to be right there. So you just draw an open circle there. So it looks like we really don't need another point to the right of the vertical asymptote because we can pretty clearly see what's happening here. We can connect our hole to our x-intercept, and then we're going to go towards that horizontal asymptote, and then we can connect our hole to our y-intercept, and then this is going to go towards our vertical asymptote. So this always happens when we're graphing our rational functions. It'll go towards one asymptote on one side and the other asymptote on the other side. Now, we don't really know if our function would be up here or down here. So we really need to plug in some more points to see where that graph is. So for our 3 other points, we might plug in x equals -4, since that's going to be the first x value to the left of our vertical asymptote. And so we'll plug that into our equation, and that would be -4 minus 8 over -4 plus 3. That's -12 over -1, so that's 12. So we have the point -4, 12. For the next point, we could plug in x equals -5. So that would be -5 minus 8 over -5 plus 3. That's -13 over -2. That's 13 over 2. Now again, to graph, it's usually easier to look at this as a mixed number. So this would be 6.5. So we also have the point -5, 6.5. And we could plug in -6 or -7, -8, -9, -10. It doesn't really matter. I'm just going to skip over to -8. So that would be y equals -8 minus 8 over -8 plus 3. So that's -16 over -5. That's 16 over 5. That would be 3 1/5. So we also have the point -8, 3 1/5. So let's go ahead and plot these 3 points that we found. And just to be clear, we didn't have to find 3 points to the left of the vertical asymptote. If you feel comfortable with where the function would be, then you could have plugged in -2, you could plug in -1, or any other x value that we didn't already have. So let's plot -4, 12. So that's going to be up here. -5, 6.5. -8, 3 1/5. So that's about right there. And now we can connect our points with a nice smooth curve. Make sure you're really connecting your points here. And make sure that you do not cross this vertical asymptote here. This is going to approach the vertical asymptote, and do not cross this horizontal asymptote. Now your rational functions can technically cross through a horizontal asymptote. Usually that will happen for smaller values of x if you have 2 vertical asymptotes. But in this case, the horizontal asymptote really serves as showing us the end behavior. What the y value is as x approaches negative infinity and approaches positive infinity. Now the only thing left is to find the range. Now the range, there's certain y values that this function cannot equal in this case. It does not equal the y value of your whole. That is always an automatic restriction for your range. Y cannot equal negative 5, 6. If you have a whole there, that means that y cannot equal that number. Now also in this case, since we're not crossing the horizontal asymptote, our y value will never equal 1. And so y can also not equal 1. I hope you've learned a lot during this video. Thank you for choosing Math with Caroline. Please give a thumbs up, subscribe, share this video with your friends, and leave a comment. Thank you so much.